Phosphorus. It's in our DNA. It helps power our cells, and it's a fundamental building block for all life as we know it. But have you ever wondered where this crucial element came from? It wasn't always here. The Big Bang created only the lightest elements: hydrogen, helium, and a tiny bit of lithium. Everything heavier, including the phosphorus inside you, had to be forged in the hearts of stars. For years, scientists thought massive stars and their spectacular supernova explosions were the primary source of phosphorus in the universe. It made sense. These cosmic blasts are responsible for creating and scattering many heavy elements across the cosmos. However, recent studies have revealed a more complex and fascinating story. Research using advanced spectroscopic analysis, which is like a chemical fingerprint for starlight, has started to paint a different picture. Scientists observed that supernova remnants didn't contain as much phosphorus as their models predicted. If these explosions were the main factories, there should have been a lot more of it left behind in the cosmic debris. This discrepancy led astronomers to look elsewhere. If not from the dramatic deaths of the most massive stars, then where did life's essential element originate? The answer, it turns out, might lie in a different kind of stellar event. The focus shifted to a specific, and perhaps less dramatic, type of cosmic explosion known as an oxygen neon nova. These are thermonuclear events that happen on the surface of white dwarfs, the dense remnants of sun-like stars. A white dwarf in a binary system can pull material, mostly hydrogen and helium, from its companion star. This material piles up on the white dwarf's surface, getting hotter and denser until it triggers a runaway nuclear reaction. This explosion is a nova, a sudden and incredible brightening of the star that spews newly forged elements out into space. And it's within these fiery blasts that the conditions are just right for creating large amounts of phosphorus. A study published in the journal Nature Astronomy provided compelling evidence for this. Astronomers observed a nova called V4332 Sagittarii and detected significant quantities of phosphorus being ejected from it at incredible speeds. The observations suggested that these novae could be a major source of galactic phosphorus, potentially creating much more of it than supernova do. It's a classic scientific tale of a long-held assumption being challenged by new data. So, how does it work? During an oxygen neon nova, the extreme temperatures and pressures on the white dwarf's surface initiate a chain of nuclear fusion reactions. Lighter elements are fused into heavier ones. The process creates a cascade, building up from lighter nuclei to progressively heavier ones. Under these specific conditions, the reactions are incredibly efficient at producing phosphorus-31, the only stable isotope of the element. Think of it as a cosmic production line. The white dwarf provides the factory floor. The stolen material from its companion is the raw input, and the nova explosion is the manufacturing process that churns out the finished product, life-giving phosphorus. This new understanding helps solve the mystery of the missing phosphorus from supernova and gives us a more complete picture of our cosmic origins. It shows that life's ingredients weren't just made in the most violent events imaginable. They were also created in the outbursts of stellar remnants, a more common and widespread phenomenon throughout the galaxy. It means the building blocks of life might be more evenly distributed across the cosmos than previously thought. Every atom in your body, except for the primordial hydrogen, has a stellar story. The phosphorus that forms the backbone of your DNA was likely forged in the fiery flash of a dying star's final, brilliant outburst millions or billions of years ago. That material then traveled across interstellar space, mingled with gas and dust clouds, and eventually coalesced to form our solar system, our planet, and ultimately you. We are all, in the most literal sense, made of stardust from a variety of cosmic sources. The universe is a vast and intricate chemical laboratory, and we are only just beginning to decipher its recipes. The story of phosphorus is a powerful reminder of our profound connection to the cosmos. What other cosmic secrets are waiting to be uncovered in the light of distant stars? We're always looking for the next piece of the puzzle. Thanks for watching. If you want to explore more amazing stories from our universe, be sure to subscribe to Space Repo.